All right. Good afternoon, everyone. Welcome on behalf of the Granger College of Engineering and the CS department. It's my pleasure to welcome you to this investiture ceremony, where we will recognize 4 remarkable faculty members from the CS department. We will have the investiture ceremony for Arindam Banerjee as the founder professor in computer science, Chandra Chekuri as the Paul and Sandy Saylor professor in computer science, Tandy Warno as the Granger Distinguished Chair in engineering, and Nancy Amoto as the Abel Bliss professor in engineering. My name is Philippe Gobel. I'm the Executive Associate Dean for the Granger College of Engineering, and I'll have the pleasure to MC this ceremony today. It's actually one of the joys that we have in our job, is to participate in these special events. As we look forward to today's ceremony, I would like to introduce you to some very special people who are here to share in this celebration. Chandra is joined today by his wife, Susan, and 2 children, Rahul and Mira. Would you and any other attending family please stand? They're not here yet. All right. When they show up, please, we will recognize them. Tandy is joined today by her husband, George. Would you and other member of the family please stand? Oh, he's over there. All right. Nancy is joined today by her husband, Lawrence. Please stand. So without a doubt, balancing the demands of work and family responsibilities can be a challenge, and it wouldn't be possible without the strong support that you all get. So thank you all for your continued and unwavering support of our valued colleagues. So considering the importance of named professorship and chairs to the University of Illinois, it is fitting that we start this ceremony with remarks from the university perspective. We are honored to have with us today Bill Bernhard, who's the interim Vice Chancellor for Academic Affairs and Provost on this campus. As the interim provost, Dr. Bernhard oversees the campus's academic programs, policies, and priorities. Prior to holding this position, he was the Executive Vice Provost of Academic Affairs and previously served as the head of the Department of Political Science. So please join me in welcoming Provost Bernhard.
Thank you, Philippe. It's good to see everyone today. I'm very excited to be here on behalf of the Chancellor to celebrate this wonderful set of investitures. And there's only one thing better than celebrating an investiture on our university, and that's the opportunity to celebrate 4 at one time. So let me offer my congratulations on these richly deserved recognitions. It is certainly a great day for all of us, and certainly great public recognition of the impact of the Department of Computer Science and the Granger College of Engineering on our campus and in our world. I don't think there are any more visible impacts in public universities than the endowment of chairs, professorships, and fellowships. These gifts are not just direct investments in people, but also in ideas and human potential. They feed the heart of our university and serve as strategic tools to attract and retain top scholars. And most importantly, they are our way to recognize those who excel in their work while opening new avenues of exploration and debate. These celebrations of the highest academic honors are also an opportunity for us to reflect on our shared purpose and vision. Our strategic plan states that our goal as an institution is to be the top research university with a land-grant mission. And that land-grant mission means that we have a responsibility to lead in discovery and innovation that addresses fundamental issues for society, that we teach students from all walks of life to equip them with the knowledge, skills, and vision to become leaders in their communities and beyond, and that we fully engage with the communities that we serve, that we don't hide away in an ivory tower, but we share our knowledge, we share our gifts, we share our contributions with the people and our neighbors, both near and far. That mission for our university, that land-grant mission, means that we expect more out of our faculty. It's not enough to be a leading expert in the field. It's not enough to publish papers or to attend conferences. It means instead that we expect our faculty to apply their expertise to solve fundamental real-world problems and to share that knowledge with students and practitioners and the public. Clearly, the remarkable scholarship, research, and teaching of Professor Banerjee, Professor Chikuri, Professor Warno, and Professor Amato meet that incredibly high standard. Their distinguished records of accomplishments represent what it means to be a faculty member at our institution, and their sense of service and leadership help propel the department and the college to even higher levels of visibility and impact. We look forward to hearing about the depth and impact of their work throughout this afternoon. So let me just one more time offer my congratulations on the significant milestone in your careers. I don't need you to tell you that the Granger College of Engineering and our Department of Political Science are among the best anywhere in the country, and I know that you would be welcomed at many of the top universities around the globe. Thank you for making Illinois your faculty home. Thank you for all your contributions to our campus and our community. We look forward to celebrating with you even more achievements in the future. Thank you.
Thank you very much, Provost Bernhard, for being here and sharing with us today. So we will begin today with Professor Arindam Banerjee as Founder Professor in Computer Science. Founder professorships are made possible by the Granger Engineering Breakthrough Initiative, or GEBI, the result of a $100 million investment in the Granger College of Engineering by the Granger Foundation. The initiative supports multi- and interdisciplinary study and provides a springboard for groundbreaking projects by allowing the college to invest in strategic priorities, including faculty chairs and named professorships, undergraduate scholarships, facilities and infrastructure, and research support. Founder professorships have helped the college to recruit and retain world-class faculty and contribute to our elite science and engineering program. So considering Arindam's academic career has been long and distinguished, there's no possible way for a short bio in an event program to tell us all that he has done to be so deserving of this recognition. Arindam's friend and colleague, Professor Smith, has graciously provided a recording to introduce him. Professor Smith is a Chancellor's Professor of Computer Science and Statistics, Associate Director and Founding Director of the Center for Machine Learning and Intelligent Systems, and Founding Director of the Data Science Initiative at UC Irvine. So please bring your attention to the screen to hear a few words from Professor Smith.
Good afternoon. Thank you for inviting me to participate today in the investiture of Professor Arindam Banerjee. It is a very great honor and also a great pleasure to be asked to provide remarks about Arindam. Arindam is one of the top researchers in the world in the field of machine learning. He is such a modest fellow that you might not be aware of his stellar reputation in the field from talking with him. But there are few other researchers that have the respect that he has in machine learning. What has always impressed me about his research work are two aspects in particular. The first aspect is his ability to pick important foundational problems in machine learning and to produce results on these problems that have lasting impact. The many citations to his work provide clear evidence of this impact. The second impressive aspect of his work is the exceptional insight that he brings to bear on whatever problem he focuses his attention on. His papers invariably tie together a broad range of conceptual ideas, opening up new directions for future research in a manner that few other people in the field of machine learning are able to pull off. I realize not everyone in the audience will be familiar with the details of research in machine learning, but let me make a few comments that are a little more specific about the nature of Arindam's research. Arindam's research work spans both foundations and applications. The foundational aspects of his work in machine learning include statistical aspects of learning, mathematical results and optimization algorithms, analysis of machine learning for high-dimensional problems, and much more. In addition, on the application side, his work includes important contributions of machine learning in areas such as climate science, ecology, and medicine. This interface of basic research and applications-oriented work is critical for the field of machine learning research, in that the foundational research drives new applications by providing the mathematical, statistical, and algorithmic frameworks on which the field is founded. While in parallel, the applications challenge the foundational research to come up with new theories and methodologies that enable new scientific discoveries, new medical treatments, and so on. Few researchers have the skills to successfully build these essential bridges between theory and practice. Arindam is in this small select group. In this context, let me briefly highlight two outstanding examples of Arindam's research, one foundational and the other in applications. The first paper I will highlight is titled Clustering with Bregman Divergences, published in 2005 in the Journal of Machine Learning Research. This is the highest impact journal in the field of machine learning. The paper has almost 2,000 citations to date and is still getting over 100 citations a year. The paper addresses one of the more important and core problems in machine learning: how to automatically discover structure from data. At the time of the writing of the paper by Arindam, prior widely used methods were empirically effective, but ad hoc in nature and lacked theoretical foundations. Arindam's paper unifies these ideas within an elegant general framework, providing completely new and powerful perspectives. This paper is a tour de force. It's a wonderful paper that exemplifies the elegance and depth of Arindam's contributions to foundational aspects of our field. The second paper is much more recent. It describes a system called TorchGeo for deep machine learning with geospatial data. The paper appeared at the ACM SIG Spatial Conference just a week or two ago. This work describes a new and potentially transformative software library for researchers to integrate machine learning into their scientific workflow. I'm excited to see how Arindam's new work in this direction will accelerate the geospatial scientific discovery process in a meaningful way. These two papers clearly highlight the versatility and impact of Arindam's research contributions. It was actually quite difficult to just select two papers to highlight, since Arindam has many wonderful papers to select from. In closing, on a more personal note, let me heartily congratulate Arindam on this investiture. In addition to his tremendous contributions to machine learning research over the years, Arindam is a wonderful professional colleague, a delight to meet in person, and an inspiration to all of us in the field. Arindam, congratulations on your investiture. It is very well deserved. Thank you.
Thank you, Professor Smith, for your words. Please join me in welcoming Dean Rashid Bashir for the investing of Professor Banerjee.
Good afternoon. Good afternoon. All right, thank you. It's great to see you all here. I think as Philippe said, and I know Bill said that too, this is really the best part of all of our jobs, to be able to celebrate and recognize our wonderful colleagues. I think the people, the great people that makes this place great. At the end of the day, I have always said that everything that we have around us, whether it's the buildings, the infrastructure, even the students that come, I think a lot of it is because of all the people that we have. We have excellent people, and that makes this place excellent, and we're just so thankful that these four colleagues from computer science are all here with us today. They could choose to be anywhere in the world in any institution. I'm also especially excited because, as you know, how excited I am about computer science, and we'll talk about that through the investitures. But this is just so wonderful. It's my privilege and honor to perform the official investing of Professor Arindam Banerjee. As a founder professor in computer science, the investiture as a named professor is one of the highest honors that a faculty member can receive. And today's investiture certainly reflects that dignity and the importance of this event. On behalf of the Granger College of Engineering, let me say that just how extremely proud we are of Arindam, and thank you for being here. These named faculty positions really communicate the global eminence of our faculty in the world's academic community. They empower us to open new areas of research, new areas of scholarship, new areas of learning, and allow us to really make an impact on humanity at large. These are critical in us attracting and retaining world-class scholars like Professor Banerjee that we have here today. So today begins a new day for his career, one that encompasses and anticipates great new things that will come about, breakthroughs in knowledge and pioneering research that is really made possible through gifts like this one from the Granger Foundation. So today is a day to celebrate excellence, impact, teaching, excellence in research, excellence in service. So Professor Banerjee, would you please come forward, and I'll give you your medallion.
Projected on there, so I need to keep on the side. You're having orange and blue projected on it. Over here? Much better.
Thank you.
Thank you so much. Thank you, Dean Bashir. Thanks, everybody, for coming over here. I'm really humbled and honored to be getting this named professorship. I want to start off by thanking the Granger Engineering Breakthrough Initiative and the Granger Foundation for making something like this happen. The idea of enabling something like this and trying to do the groundbreaking initiative, it's truly, truly amazing. I want to thank a few people without whom I will not be here. And I want to say maybe a couple of words about the work we have been trying to do. So I'll start off by thanking my family, my mom, dad, my elder brother. They have been with me throughout my life. They're still my support system. They're still my friends. They're among the best friends I have. We still hang out together. We have a lot of fun. They could not be here today. Hopefully they'll be able to, so I'll share this with them. The second person growing up in a small town in India, I'm truly indebted to, is one of our neighbors, Professor Arun Bose. And he opened doors for me as a teenager, which I think, unless he was around, my trajectory would have been different. So he gave me access to various kinds of books from all over the world, mostly related to math and physics, because I was really enjoying that. But among the many things he did, he gave me a copy of this book called The Emperor's New Mind by Roger Penrose when I was a teenager. He knew fully well I'm going to struggle through that book, but I had a lot of fun, and over the next 15 years, I slowly started understanding the various facets of that book. But I got completely hooked to AI and computer science as a teenager, thanks to him and thanks to partly this book. Although it's a highly debated book, and we can argue what is right and what is wrong about that book, but it's definitely thought-provoking. So I'm still indebted to him. I'm still in touch with him. He has grown over the years. He's still the sharp individual I knew as a youngster. I want to thank my advisor, PhD advisor, Professor Joydeep Ghosh at University of Texas at Austin. So what he provided was what I would call is a very nurturing environment. And I'm still, after 15 years being a faculty, I'm still trying to get what he was doing. Every year passes by, I have realized what an amazing job he did, right, in his group. So he gave us the exposure to the breadth and the depth, exposing us to interesting problems. And I've realized that he would stand back and let us sort of start digging in, because once you start latching into things, then your growth started. And the more I think about it, I feel this form of advising and mentoring as a form of gardening, right? So you're not going to plant seeds and immediately get flowers the next day. You have to put water, you have to wait for the flowers to come out. And I'm still trying to get to that level, in terms of my advising and mentoring responsibilities. My students are doing fantastically well, and the new students are coming in, but I'm still aspiring to match up what he has demonstrated when I was his PhD student. I have to actually thank my colleagues and collaborators and students over the years. It has been a fascinating journey. It's so exciting to be working with such driven people who are really sort of focused on the work, excited about what they're doing, whereas they could be doing many other things, and this is what they're choosing to do. And the kindness and generosity of people sort of all across the board. There are inspirational people. There are people like Professor Perek Smith that, growing up as a graduate student, I would look up his work. I would get truly inspired by what amazing work he's doing. And it's truly an honor to become colleagues and collaborators with some of them over the years. I want to thank Professor Jiawei Han. He's a giant in our field of data mining, data sciences, in all of computer science, right? So he's a towering figure, and many of you know this. I'm really appreciative of Professor Han for broaching this subject and approaching me that whether I would be interested in coming here. I'm truly grateful for you initiating that, and I'm thankful for that. And I'm still, I'm in awe of the work you do. Hopefully we'll be able to sort of do at least a fraction of the work you do someday. I want to thank the department, Nancy and the department leadership, the colleagues. I'm new here. Most of you have not seen me on campus. That's why this is my second year here. I sneaked in during COVID. And I have not managed to meet many of you, but hopefully that will happen. I like collaboration. I like talking to people. I'm slowly trying to build some of these connections on campus. Hopefully we'll be able to do ambitious things going forward. But I really appreciative of the department, of the department leadership, the colleagues there, the students there welcoming me into the department. But I'm still new. Hopefully there'll be more interactions, good things happening. And then I want to thank Mishi Roy, my dear wife and friend and partner, who is not here today because she is now a chief resident at Duke Neurology. So she runs 80-hour weeks, running around, taking care of patients, and so on and so forth. Hopefully we'll be able to get her to the Urbana-Champaign area soon. So we are working on it. We are making some progress. But we have known each other for over 15 years. We have become more than just husband and wife. We are the closest of friends. And I would say that I would not have been in this position if she was not around. Without her, none of this would have been possible. We both challenge each other and we support each other. That's how it goes. So I'm really thankful. She's probably in her clinic right now seeing patients, but I'll tell her that we had this session. I'll say a couple of words about the work we are trying to do. So I work in AI and machine learning. I have been doing this. I've been interested in this since as a teenager, as I said. And over the last 10 years, the field of AI and machine learning has really taken off in some sense. And there's a bit of celebratory mood in there. I think that's a bit premature, right? So many of the world's biggest problems are actually waiting to be solved. And a couple of these things that drive my work and interest are, we are worried about the changing environment, the change in climate, and the impacts that are having. So there is a scientific storyline to it. We really want to understand climate change that's happening. Our environment is changing. Everything, our ecosystems are changing around us. The second bit is the impacts, which we are all starting to see around us, right? So these include extreme weather events like floods and droughts and forest fires and tornadoes and hurricanes, heat waves and cold spells. So we have to start thinking about these are real problems. They're affecting people's lives. They're devastating, right? So if your neighborhood has gone through one of these, you know that how devastating they are. We have to start understanding these problems. We build technology, but there's a huge human side to these things that are showing up. And I'm hoping we'll be able to form big collaborations and go for these problems slowly, rather than staying, as was mentioned, in our ivory towers working on these select problems. I think this is changing our planet. This is impacting people. This is impacting our planet. So that's something sort of drives me at the core. And even in the steady state, you do understand that by 2050, we will have to feed 9 to 10 billion people and provide water for them. These are grand challenges, right? So they need a multifaceted plan of attack. And I'm hoping now that we have had some success in AI and machine learning, and the technology is starting to mature, and I'm hoping really we'll be able to take on these grand challenges at the UIUC and also form collaborations across the board. I think that's all I have. Thank you so much. I really appreciate this.
Thank you, Professor Banerjee, and congratulations again for being named the founder professor in computer science. Next, I would like to introduce Professor Chandra Chekuri as Paul and Cindy Saylor Professor in Computer Science. This professorship was established in 2005 through the generosity of the late Gene Golub in honor of his long-standing friendship with the Saylors. Professor Golub's influence on the theory and practice of scientific computing was profound, both through his vast range of technical research contribution and his professional leadership of the entire scientific computing community, both nationally and internationally. The late Professor Emeritus Paul Saylor served on the computer science faculty at the University of Illinois since 1967. He received his PhD in mathematics from Rice University in 1968. His research interests included high-performance computing and the solution of large linear and nonlinear systems, with application in astrophysics, electromagnetics, and groundwater flow. His research focused on constraint problems, specifically in relativity equations. Paul and his wife Cindy became acquainted with Gene Golub during Gene's many visits to Illinois, and they remain his lifelong friends. Gene wished to honor their kindness, support, and generosity, as well as Paul's dedication to his students and the academic life through the naming of this endowed professorship. Chandra is joined today by his colleague and friend, Professor Sanjeev Khanna, here to introduce him. Professor Khanna is the Henry Salvatori Professor of Computer and Information Science at the University of Pennsylvania, where he has had a celebrated career and made several fundamental contributions to theoretical computer science and combinatorial optimization, ranging from approximation algorithm, hardness of approximation, and sublinear time algorithms. Please join me in welcoming Professor Khanna.
Thanks. So it is my great pleasure to be at this celebration to recognize my dear friend Chandra as the Paul and Cindy Saylor Professor in Computer Science. I have known Chandra since graduate school days. He started his PhD just a year after me, and we shared the same advisor as well as the same office. After graduation, I joined Bell Labs, and lo and behold, just a few years later, Chandra also joins Bell Labs. We have collaborated on many research projects, starting with our time at Bell Labs. And I see all this as part of my great fortune that I had a chance to work with a researcher of his amazing capabilities, and even more importantly, to deepen my friendship with this extraordinary person. Chandra has worked on several fundamental problems in combinatorial optimization, and he has made spectacular advances throughout his research career. He has done deep and influential work in approximation algorithms for network design and routing, submodular function optimization, and scheduling problems. In fact, within just a few years after his graduation, Chandra had already solved some long-standing problems in scheduling theory. One of Chandra's most influential bodies of work is on the disjoint path problem, which tackles the very basic question: how do we route in a network without causing congestion? The disjoint path problem has fascinated both computer scientists and mathematicians for decades, and the study of this problem is at the heart of major developments in both algorithms and graph theory. In its full generality, the problem is known to be NP-hard, and despite being a focus of intense study, in the early 2000s, we knew very little about efficiently computing good approximate solutions to this problem. Starting in 2004, Chandra wrote a sequence of papers which developed a new framework for solving routing problems like disjoint path problem. And this framework was a paradigm shift in algorithm design for disjoint path and many other related problems. In the decade that followed, building on this framework, Chandra and others made major breakthroughs on disjoint path problems, including achieving polynomial bounds for the celebrated grid minor theorem of Robertson and Seymour. I consider this entire body of work to be among the most significant and influential set of results in all of combinatorial optimization. Chandra has made pioneering contributions to many other areas. His work on submodular functions has led to the best known bounds for a remarkable number of problems with long and rich histories. Some of his more recent work has focused on using the multiplicative weights framework to develop surprisingly fast algorithms for solving relaxations of NP-hard problems. Over the years, as Chandra's research focus has moved from one exciting area to another, there has been one constant. His work often reveals deep new insights and connections between earlier works that were often overlooked by others. It is this clarity of thought and deep intuition about optimization problems that has allowed him to obtain ultimate results for so many well-studied problems. In my collaborations with Chandra, I have learned a great deal from both his incredible research creativity and instinctive generosity towards everyone around him. I think any institution would be fortunate to have a scholar of Chandra's caliber, a colleague with his level of warmth and generosity, and a mentor and educator with his level of insight and intuition. He's simply all around exceptional. And I'm thrilled to see Chandra receive this highly deserved recognition. Thanks.
Thank you, Professor Khanna, for your words. So at this point, I would like to invite Dean Bashir again for the investing of Professor Chakuri.
Thank you, Philippe, and thank you, Professor Khanna, for being here. I know it means a lot to Chandra and to all of us for you to travel all the way here and be here for this important event. So thank you. It's my privilege and honor to perform the official investing of Professor Chandra Chakuri as the Paul and Cindy Saylor Professor in Computer Science. On behalf of the Granger College of Engineering, let me say how extremely proud we are, Chandra, of you and your accomplishments. Would you please come forward? I think, again, these events are, like I said, the best part of our jobs. And I think Philippe and I both agree that this weighs much higher than the budget meetings we have with the department heads or the provost. So, yeah, thank you all for being here. Please.
Good afternoon. Yeah. Yeah. So thank you so much. Thank you, Dean Bashir. Thank you, Sanjeev, and thank you, Nancy. It's a great honor and pleasure to be here, and I'm very happy to share this today with amazing colleagues, Arindam, Tandy, and Nancy. And I think it's also nice that we're all theoreticians at heart, I think, even though Arindam is maybe doing many, many important things in applications. I think we're all theoreticians at heart, and it's very nice that four of us, as a coincidence, are being celebrated today. There are several distinguished visitors, many colleagues, students, staff, and friends and colleagues here, and it's wonderful. Thank you all for coming. I want to start off by thanking the Department of Computer Science and Granger College of Engineering and the University of Illinois for the incredible support they've given me over the years since I joined. It's been a great place for me professionally and also socially, and I have so many friends here. And not only in computer science, but I have wonderful colleagues in many departments, ECE, ISC, math, physics, and across. And so it's been a truly rewarding time for me for this last 16 years. And I know that awards like this take a lot of effort from many people, nominations, letters, and committees, and so on. Thank you all for making this happen. I'm especially pleased to receive this Paul and Cindy Saylor professorship. And I still recall vividly Gene Golub in the department when I was a graduate student there. They had just split, when I joined, they had just split the scientific computing group from computer science. I think maybe it's not the best move given the importance of linear algebra and continuous optimization in today's world of machine learning and many other areas. But that's what happened in those days. And of course, Gene is a giant both in terms of scientific accomplishments, and also he was an imposing person. And I think, in those days, I didn't really appreciate the importance of continuous optimization and numerical linear algebra. But there has been a revolution in both, of course, machine learning and also in discrete algorithms with these interactions. And I think a small part of my work connects to that. And I hope I can do more at the interface of discrete and continuous optimization. Professor Saylor retired by the time I got here. I saw him a few times, but I really didn't know him well. I'm really pleased to be associated with these two amazing scientists, and also because of their deep connections to U of I and Stanford, two institutions that are dear to me. My main goal here is really to express gratitude to many people who supported me and are important to me. And unlike Tandy and Nancy, who this is my first Oscar, as I say. So I allow me to take a few minutes extra, maybe, to thank people, right? In addition to U of I spent 8 formative years at Lucent Bell Labs, and of course my PhD at Stanford, and also 4 wonderful years at Indian Institute of Technology in Chennai. I met many fantastic people at these places who taught me, inspired me, and I also formed many deep friendships which last to this day. 2 mentors. I think everybody deserves fantastic mentors like I did. I had 2 mentors in my life deserve particular attention. The first is, of course, Sanjeev, who you met just a little while ago. As he said, I met him during my very first year at Stanford, and I was kind of in a panicky mood because I was trying to find an advisor, and things weren't going so well with something else. And somehow, he put in a good word to Rajiv, and then I became Rajiv's student, which is wonderful. I really don't know what he saw in me. I was just fresh off the boat, as they say, right? And now I think about it, maybe it was a mustache in those days, right? Because, I showed that picture to my kids, and they didn't think I was the same person, okay? So it was an amazing collaboration. He is an amazing friend, incredible collaborator and mentor, and an inspiration via his own wonderful and diverse and outstanding work. The second person and second mentor who had a really deep influence on me is Bruce Shepard, who I met at Bell Labs when I joined. He's very different from Sanjeev in many ways, but he also took me under his wing. He taught me, I think, many aspects of combinatorial optimization and graph theory, which really changed, I think, my outlook and post-PhD trajectory. From him, I think, learned to appreciate structural aspects of algorithms. I think Sanjeev too, I think. So I changed in some ways. And most importantly, Sanjeev, Bruce, and I had so much fun and excitement working together in those years. It's really a highlight of my life. And I was with Sanjeev at Cafe Paradiso just this morning, working and thinking about some old problem. We haven't really spent much time working in the last, 10 years or so, but we just were thinking about some old problem and really brought back wonderful memories of our trips to Manhattan or wherever we'd go and work in coffee shops, and it was really a great time in my life. In addition to Sanjeev and Bruce, I've been lucky to have had several influential collaborations over the years. I wish to mention a few. My very first collaborator, Kasturi Varadarajan, when we were undergrads trying to figure out what research was all about, we wrote some paper which never saw the light of day, but still I am proud of it. My late advisor, Rajiv, for all his help. Many fellow Stanford students, Don Angworth, Moses Charika, Rashish Goyal, Sudipta Guha, Piotr Indik, which is a great time there. I learned a lot on submodular optimization through my collaborations with Gruia Kalinescu, Martin Pal, Jan Wondrak, and Rico Zenklusen, and also Julia Chuzai for our nice work on structural graph theory. I came to Illinois in 2006. It's been already 16 years. It's been a great time. And my next adventure started after Bell Labs. My great pleasures here have been teaching, which I really enjoyed from when I was a kid, working with wonderful students, and meeting a whole new set of wonderful colleagues and friends with collaborations, just chats, and so on. I have and continue to have the privilege of working with some fantastic group of students over the years. Had wonderful students who have gone on to their own careers, and they've proved things that I wish I could have done even today, and it's so great to see them. I see some of my current students here, and I hope they are inspired by the ones who came before, and they'll pass on their thing to the next generation. The theory group in the CS department has been really a home within the home for me. It's a great group. We are so very cohesive and friendly, and I don't think of the students as really my student or my colleague students. They work with many of us, and I want to thank Jeff, Sariel, Lenny, Madhu, Mahesh, Robin, Ruta, Dakshita, Timothy, and all of you for making the theory group such a wonderful place. I want to especially thank Sariel, because I think he's the one person I speak to the most in my career here. Every day, almost, whenever I'm there. So it's very nice. I want to thank the families of my colleagues and friends, Pramod Vishnath and Romit Roy Chowdhury, especially for their support and friendship to my family. Kent Conrod, my student, has been an important friend over the last several years, especially during the pandemic. I talk to him more frequently than too many other people, and I want to thank him for that. Finally, or not last, but my family is so important to me. My fiercely loving and protective mother and my generous and outgoing father provided me the foundation and values to be a good citizen, and I owe them a lot. But I owe a tremendous amount to my wife, Shamim. She came to my life at a critical juncture when I was not in great shape. A lot of things going on, and she pulled me up and kept me going, and her love and support sustained me through the last 20 years. Thank you, Shamim. My two children, Rahul and Meera, right? They teach me almost daily about patience, for sure, vulnerability, and love. So, and they make so much fun of me for my apparent shortcomings, right? So they keep me grounded, for sure. When I reflect on my career so far, I feel like I've stumbled on some good problems and directions over the years. I don't know, mostly by chance, I think. It's hard for me to figure out, but I have had some good luck in that. One constant has been my desire to understand and simplify complicated ideas, and I think that has been a motivator for my teaching and also raising some perhaps interesting questions that I've enticed my collaborators and students to work on and solve with me. So, like many in our profession, I go through ups and downs. I think it's not always acknowledged that it's a tough business, right? At least as a theoretician, right? It's a great joy when I get a new idea or maybe a new problem. But I do go through periods when I don't know where the next theorem is going to come from. So it's, but I've learned that I'm not alone in feeling this way. Even very accomplished people tell me, right, that they also go through this way. Right? But when I feel this way, I think something about what my colleague Saurabh Sinha told me once, which I try to remember, even though it's hard. He said, isn't it amazing that average people like us get to spend most of our time thinking about our own ideas and get paid to do it? Why are you complaining, right? So I think in that spirit, let me conclude by appealing to a wonderful song that I love in my mother tongue Telugu. This is by the great poet and Saint Tyagaraja, and the song is titled in Telugu, Endaro Mahanubhavulu Andariki Vandanamalu. I don't know if anybody here knows Telugu. I look around, I don't think so. Okay, my kids should know, but they don't. Okay. So what it says is that, there's so many amazing people. My salutation to all of them. And I want to say that it's indeed a great privilege to be part of an intellectual journey that so many amazing people contribute to, and also be paid to do it. Thank you all for coming and joining the celebration of the collective journey that we all undertake for excellence and progress.
Thank you, Professor Shukuri, and once again, congratulations for being named the Paul and Cindy Saylor Professor in Computer Science. Next, I would like to introduce Professor Tandy Warno, the Granger Distinguished Chair in Engineering. Granger Distinguished Chairs are made possible by the GABE initiative that I mentioned earlier. This is the initiative that has had such a big impact on our college in allowing us to attract and to retain top-notch faculty members like Professor Warno. I won't go over the details since I've done it already about the Granger initiative. Instead, I would just like to mention something that I discovered about Professor Warno recently, the fact that she taught herself French, which was superb, really remarkable. At the last meeting that I had with her on the many leadership roles that she plays in our college, she actually asked that we run the entire meeting in French, which was, I'd like to emphasize, very hard for me because you have to kind of turn your brain from one language to the other. But I was very impressed. So I will not require all meetings to take place in French, but I was delighted to have that meeting with you. But clearly, we need to have someone to tell us more about her scholarly work and her many contributions to the field. And to do this, we have Tandy's friend and colleague, Professor Dan Gusfield, who will introduce her. Professor Gusfield is Emeritus Distinguished Professor of Computer Science at UC Davis, but he grew up here in Champaign-Urbana. So please join me in welcoming Professor Gusfield to the stage.
Well, it's wonderful to be back here in Champaign-Urbana. Tandy and I were talking earlier about when we first met, and I was saying I can't remember a time before Tandy. It just always has been there in my professional life and as a friend as well. So Tandy actually, she got her PhD at UC Berkeley, and I was on her thesis committee as well. And suggested a problem to her that I had worked on earlier and made no headway on, which was called multi-state perfect phylogeny. And it was a problem where there was beautiful mathematics, but nobody knew how to turn that mathematics into algorithms. And as I said, I worked on it for about 6 months and failed. Introduced it to Tandy, and she, as a graduate student, along with Sampath Kanan, made tremendous progress solving special cases of 3 states and 4 states. And then later there was a general solution, or more general progress, by another sort of student I was related to or involved with. But then Tandy and Sampath went back to that problem, went back to that paper, and made it even better. So that is now the go-to paper on multi-state perfect phylogeny. And it's really beautiful, it's brilliant. 20 years later, I went back to multi-state perfect phylogeny, and so with some of my students, worked on that same problem again from another standpoint, and spent many, many hours studying Tandy's paper and work. So Tandy's work is in computational phylogenetics, algorithms for studying evolutionary trees, for creating evolutionary trees from various types of data. And this is an area that's enormous in real biology. Real biologists build evolutionary trees in all kinds of contexts, but they don't have much theory behind it. They don't have much sense of a measurement of who's doing well and who's not. I was saying today to a number of people that it's kind of like the papers in hardcore biology that you read today could have been written 50 years ago. There's in that sense no real progress among the biologists. So it's among the computer scientists and mathematicians who have really stepped in and provided a theory and a framework and ways of measuring, are we doing well or are we not? Or when can we do well? Or what are the constraints on these problems? And Tandy has been at the forefront of that effort and success in creating a real theory of phylogenetics. In all aspects of phylogenetics, both statistical, combinatorial optimization, applications. She was either a co-PI or PI on the Tree of Life project from NSF to do computation for evolutionary trees for the entire range of life. And so both in practical impact and in theoretical, she's just always been a central person in that. And it's even broader than pure phylogenetics. One of the critical things one has to do before you build an evolutionary tree, at least now from sequence data particularly, is align that data, show how it lines up so that you can see the commonalities that run through the data and then use those commonalities for building those trees. And Tandy has been a real leader and a pioneer in multi-sequence alignment, multiple sequence alignment, which allows for seeing those commonalities in the data. And in other applications, such as in linguistics. Finally, this is all about building evolutionary trees. So trees branch and they don't come back together. Some people realized some time ago that trees aren't always enough to capture real evolutionary history. You have to also have networks, DAGs, directed acyclic graphs, where the history comes back together and joins for a variety of biological reasons. And Tandy was at the forefront of that as well. And I always find it amusing, every so often there's an article in the New York Times or something like that where they say, scientists have recently discovered that evolution isn't just totally tree-like, but some of it comes back together and you need networks. But Tandy and others knew that long ago and started really that field of algorithms and mathematics for studying networks rather than just trees. And well, actually in that, speaking of networks, Tandy's had great students, but this reminds me of, or makes me think of probably her most prominent one, Louis Knockley, who is also a leader in phylogenetic networks. And he went on to be a department chair at Rice and then a dean of engineering at Rice. So a very, very successful graduate student, and I think many others as well. And finally, Tandy is, among, well, is probably, I would say, the one person who most cares about the community and people in computer science and people that we know mutually. And I really appreciate her for that concern and caring and the personal connections that that we've had. So congratulations. You certainly have deserved this, and it's wonderful that I've been able to participate in this celebration. Thank you.
Thank you, Professor Gusfield, for your words, and thank you for being here today. So at this point, I'll ask Dean Bashir to come up for the official investment.
Thank you very much, Professor Gusfield, for being here. We really appreciate it. It's my privilege and honor to perform the official investing of the Granger Distinguished Chair in Engineering to Professor Tandy Warnow. Tandy, would you please come to the podium? I have to say that, you know, if it's true, it ain't bragging. So I can here claim credit for getting Tandy to our campus. I was a department head of bioengineering, and I think she might have been the very first founder professor. First or second? Second. Okay, second, because she's the chair now of the committee, so she knows. She was the second founder professor, and we're just so delighted that we were able to recruit her here from Austin, and also George, both of you. It's so wonderful to have you here. So thank you for being here. She's just been a great source of advice, and for me also personally, so I really appreciate that. And I know she's also, of course, as you all know, she's played some tremendous roles in the college. She's currently the co-chief scientist for C3DTI, one of the large center we have on Digital Transformation Institute. And I know she's played leadership role in the department, and now she's also chair of our GEBI committee. So thank you, Tandy, for everything you've done for the college, for the departments here.
It really is quite something to be here. I have gone through one of these once before, but I didn't start off by crying. So Dan, you're so sweet, and thank you. It is a great university to be here, and it's true, Rashid is the reason I came. The reason that I have stayed is for the other things that are so great here. And I also want to say that the community here at Champaign-Urbana is actually pretty exceptional. I have 4 neighbors here today, and David, Janet, Mike, and Connie, thank you for being there. You make a difference. Okay, so every time I come back to Champaign after being out, I'm glad to be back. There's something really nice here, and it's not like this everywhere, and it's really nice to be here. Again, partly it's the neighbors, partly it's our department, partly it's who we know on campus. I have to say, one of the things that's really amazing about being here is after 8 years of being at the University of Illinois, I know probably 3 times as many people across campus as I knew at Texas. They're both big universities, but there's a connection that happens here. You have opportunities, and you can make connections here, and it's great. I want to agree, first of all, Chandra, everything you said about how we're lucky, right? We're lucky to get paid for doing this, absolutely. It's pretty amazing to be able to follow your own desire as a researcher, which changes over time. When I got my PhD, I just liked graph algorithms. I liked pretty graph algorithms. That's what I liked. As an assistant professor, I discovered data. That changed me. Discovering data and having a perspective about data was quite an amazing experience. I started working in historical linguistics. That was amazing. I have to say I was really lucky to meet the people I met and to do research with them, because it's how you change and what you learn from people that makes such a difference. And now I'm working on new things. You know, yes, I started on graph algorithms, I started on trees, I started on things where I could just prove lots of theorems. I did a lot of stuff that involved simulations and method development and software. I got involved in historical linguistics and Indo-European, and now I'm working in scientometrics, which turns out to be tremendous fun. So we change. We change as we grow as faculty, and getting to do that and having that freedom to do it, I think it's one of the great things about being a faculty member, but also specifically in computer science. I just want to say computer science is an amazing field because it expands. And the fact that it's having such an impact around the world in so many different ways, I think is specifically important for us to remember. And I want to thank Nancy and the rest of the department for having that kind of encompassing vision that makes this department one of the departments in the world where it's happening like this. I also want to thank Dean Rashid Bashir for understanding this and also supporting it. It makes a big difference. I think the only other thing that I really want to say is that I'm personally so glad to have my position have Granger in the name. I have such impressive respect for that family, that foundation, and what they have done for this university with what I can see is very little pomp and circumstance and ego. It's just done in a very nice way. And so I'm really, really glad. I mean, I already was getting it indirectly. Now it's in my name. So I love it. I love it. Thank you.
Thank you, Professor Warno, and congratulations again for being recognized as the Granger Distinguished Chair in Engineering. Finally today, I'm pleased to introduce Professor Nancy Amato as Abel Bliss Professor in Engineering. This position was established through a generous estate gift from Helen Bliss, class of 1911, in memory of her father, Abel Bliss, who attended the University of Illinois as member of the class of 1875. Ms. Bliss graduated from the University of Illinois in 1911 with a degree in LAS. Early in her career, she taught engineering at Shreveport, Louisiana High School, and later did clerical work with the Bureau of Aircraft Production in Washington, D.C. From 1936 until her retirement in 1962, she worked for the Washington law firms of Ivan Phillips and Barker as an executive secretary. Abel Bliss Jr. entered the university in 1872 to study civil engineering, but unforeseeable circumstances pressed him to leave before completing his degree. In June of 1875, the university granted him a partial certificate in civil engineering. His business ventures included agriculture and real estate, and by 1929, he was a partner in the land development and oil production company of Bliss and Weatherby's. The investiture ceremony not only celebrates the outstanding professors being invested, but also demonstrates gratitude for the generosity of our remarkable donors. So we are pleased to have Nancy's advisor, Professor Franco Preparata, here to provide a more in-depth introduction. Professor Preparata is Emeritus Faculty of Electrical and Computer Engineering at Illinois and Emeritus Faculty of Computer Science at Brown University. Please join me in welcoming Professor Preparata to the stage.
Good afternoon. Good afternoon. I'm honored and pleased to be here to celebrate the formal investiture of my former doctoral students, Professor Nancy Marie Amato, the head now of this distinguished department, as the Abel Bliss Professor of Computer Science. I'm honored because of this important further event in the professional progression of Nancy, and also I'm pleased to be back to this remarkable campus, which for a quarter of a century has nurtured and helped my professional growth. And I'm honored for the significance, really, of this event in Nancy's life. In the late 80s, when Nancy joined our research group, Nancy, after she joined us after a remarkable academic progression at Stanford and Berkeley. At that time, we were housed in that cubicle brick building that you can see at the corner of Springfield and Lincoln, a very Spartan building, nothing compared with the magnificent opulence of today's engineering campus. Nothing compared with it. It was a very simple thing with very simple offices of cinder blocks, painted cinder blocks, narrow vertical windows, and all of the students were housed in windowless room. My group was housed in one of those rooms with all desks, one next to the other. Definitely not a very elegant arrangement, but one that favored powerful interactions due to the physical proximity and to the relatedness of the of the research topics. And in fact, out of that proximity arose a lot of joint paper and joint research. Not only that, but the establishment of an academic family that remarkably persists to this day. Our students are linked still as if they were in the same drab building. A truly remarkable thing. And I also would like to remember the very positive, valuable collaboration of the late, unforgettable Professor David Liu of this department that disappeared last year. It was at the time when computer science was trying to emulate the prestigious status of other academic disciplines, older and more established, like, for example, physics or mathematics. In other words, that was one of the basic aims of theoretical computer science at that time. And the discipline was reacting actively to any development, any stimulation coming from the technological society. Specifically, electrical engineering was furnishing a stimulus for this development. It was VLSI, it was parallel computation, it was routing, it was all of these disciplines that fit exactly the philosophical horizon of computer science, of theoretical computer science at that time. And one of the two topics, for example, that came out of that environment were computational biology, were computational geometry, forgive me, and massive parallel computation. And remarkably, Nancy breached these two fields with an impressive thesis, of which she's bringing a copy here later to show to you. When she left Illinois, Nancy was already a mature computer scientist. She did not need anybody's advice. She knew exactly what she was going to do. And she would grow over the years, still reacting to the development of the field and developing an incredible professional personality that has been recognized by important academic societies like the ACM, the IEEE, the American Association for the Advancement of Sciences, with the most significant recognitions of fellowship. And during those years of professional growth, she was still very sensible to the way that computer science was developing, branching out in new unexplored fields at that time. She reacted promptly to any of them with important seminal results that are today recognized universally by the community. An important item is that a number of these intellectual strains assumed a very prominent role. For example, she branched out to robotics. That was not really one of the major issues when she was a doctoral student. And from robotics, I mean, her work on the very important algorithm called the probabilistic roadmap that was stimulated by robotics had important repercussion in computational biology in attacking the problem of protein folding, one of the most fundamental and difficult problems in computational biology. And so what I've mentioned at this point is a remarkable variety of topics that Nancy has contributed to. But the most admirable thing is that there is a unifying principle behind all of these topics. Is the competent use of the fundamental tools of theoretical computer science that are discrete mathematics and probability theory. And over the years, in other words, Nancy has remained faithful to the original viewpoint of the research group in that cubicle building at the corner of Springfield. Nancy, I'm truly honored and pleased to have been your academic advisor.
Thank you, Professor Preparata, for your words and for being here today. Rashid, you know the drill.
Thank you very much, Professor Preparata, for being here and for those comments. It's my honor and privilege to invest Professor Nancy Amato as the Abel Bliss Professor in Engineering. It's really my great pleasure to have her as a colleague. I just want to say a few things. So Nancy became the department head just before I actually became the dean. I think it was just maybe 6 months before that. And I think it's just been so phenomenal to have her as a partner in this phenomenal department of computer science at this time, a very unique time, clearly an inflection point where computing, digital transformation, AI, and machine learning is taking over everything. But what I really, really, truly appreciate is, I think, Nancy's leadership style, which is to really bring people together. It reminds me of a saying that my mom has, which is the bigger a tree is, the more it's closer to the ground, which means you have to be humble, you have to bring everybody along, and still keep moving forward. So I think Nancy really reflects that in my mind. She's been a very, very strong advocate of faculty in her department and really across the college in computing and how we permeate computing in almost everything we want to do, computing, data science, and other things. And also across the campus. As you know, we have 16 CS plus X's. Of course, over the years they've been built out, but there is so much more opportunity to grow. And I think it's just a testament to Nancy's leadership to be able to continue in that domain. I also have I had the pleasure of being a co-PI with her, or a co-investigator on a grant. Sorry, not co-PI. She's a co-PI. I'm an investigator in a grant, so we also collaborate, and hopefully maybe we'll publish together. But it's just really my honor to invest her as the Abel Bliss Professor. Nancy, please. Thank you.
Well, wow. It's quite an honor to be here and to, hear my advisor talk about me like that, that's, thank you. And Rashid also. Okay, so let me collect a little bit. So I did make a few notes. Hopefully I will manage to, I won't be that long. But first I just have to say I'm really, really honored to be recognized in this way. It's especially meaningful to get this honor from my alma mater, and particularly special to have my advisor here to make the remarks on my behalf. I think that's something that really will mean something to me forever. And I'm so glad that you and Rosa Maria were able to make this trip back for this event. Though I do suspect that your decision to come might have been slightly influenced by the fact that your grandson is now a PhD student in our department. Think of that, lineage that we're happening. And Lucas also spent a summer doing undergraduate research with me, my first summer back here. So I mean, it's amazing to see all these connections happening. And I have also to say, I'd like to follow, what Chandra mentioned and noted our theoretical foundations and what Tandy also mentioned. That's to me, at my core, I'm like an applied algorithms person. And it's really special to have everyone here today. And I hadn't really realized that until you mentioned that. Let me say a little bit about, my experience here as a student. Franco, you have inspired me throughout my career, and I view you as the perfect role model for a professor. You've been at the forefront of so many diverse areas of research, basically starting them. Computational geometry, parallel computing, computational biology, to name just a few. And I don't know of anyone who's really kind of been in at the ground of so many different fields. And to see that as a student, that really did give me inspiration for being open to doing so many different things throughout my career. And that made me kind of feel like that's like a normal part of research. And it's something I've fully exploited it throughout my career. You mentioned that. I mean, I feel like, I tell my students, thank you all for being here, but I feel like every, 3 years or so, I find some amazing, cool new thing to work on, and we get to do that as faculty, right? And in fact, I've not always been encouraged to do that by my other colleagues. When I was an assistant professor, they told me, oh, you should wait until you get tenure to do something new. For all of you that are thinking about an academic career, don't do that. That's why you want the academic career, so that you can follow those exciting threads. Another quality of yours, which I've tried to emulate, is your scientific rigor and research integrity. I remember that you were always critical of this practice of publishing a paper and in a conference and leaving you'd have the statement of the theorem and the proof details to come in the journal version, which might never come, right? You always advise that we should write the full journal paper and then, get through all the details done, and then you can make that conference version and send it off. I have to admit, I've not always managed to kind of follow that advice, but I still think it's the right way to do research. Now for my students. You're the reason, I see many of you here, thank you for coming. You're the reason I chose academia in the first place, and you're the reason I'm still here today. It's like, I've been thrilled to work with so many amazing students over the course of my career, including some of you that are here today. There's nothing more thrilling than sitting in a group meeting and seeing your students thrash out some exciting idea. You're just watching them fight, not fight literally, but kind of spar over ideas. And I remember the first time that happened, it was so thrilling, and I just love, that's why, I am kind of a back row person anyways, but that is one of the reasons I like to sit in the back of the room, so I can kind of just see what's happening and every once in a while speak up, hopefully not too often. But I've also been really thrilling to see you, those of you that have graduated already and gone on to realize your own dreams. And another thing, once you've gone on, it's also, so after all these years, I have students that are out there that are faculty and researchers, and they have their own students. And so I love going to conferences and meeting my grand students, and I don't have any great grand students yet, but that will come, I'm sure. And then recently, I had actually the great experience of having one of my current students collaborate. We co-authored a paper with one of my grad students. So that's a really confusing situation. You know, it can only happen in an academic family, but it's, you know, super, super fun when that happens. So I'd also like to thank our department and all my colleagues who have made everything we do so much fun, both when at Texas A&M and when I came back here in almost 4 years ago as a department head. I have to admit, you know, had I known the pandemic was coming, you know, I'm not sure what I would have decided at that time, because that wasn't the most fun time to be a department head. But even so, we were able to do a lot of really exciting things and start new projects and really new programs and research projects and bring in amazing students. And so I'm so excited to see about what we're going to be able to do now that we're getting past this and we're moving on to more normal times. Let's see. So back to now, finally, I'd most of all like to thank my family. My parents, I want to thank them for pushing me to consider options far away from home for my undergraduate studies. I'm not sure they really realized the implications of that when they were doing that, but that really gave me opportunities. So I lived in Washington State, and I wanted to go to Washington State University for college. And my mom really forced me to consider other universities, and I ended up going to Stanford as an undergrad. And that really opened my eyes to different possibilities and also gave me opportunities to go on after that. My husband, you know, Lawrence, you're my partner and research collaborator starting from graduate school. We came here to University of Illinois to be graduate students together. We co-authored papers in grad school. Many of the most exciting projects I have done have been with him, including our new expeditions project that Rosh had mentioned. That's a really amazing project. I won't take your time. But basically, we're trying to do computing with living neurons, really, seriously. You know, we're trying to build a computer that's based on chips that are based on living neurons. Can you imagine? I mean, incredible. Lawrence has always supported me, starting from creating the illustrations of the reversing trains for my master's thesis. You remember that? I couldn't do that. He used a Mac. Was it a Mac? Can't remember. It was one of the new computers at the time, because computers were new. He made the illustrations for my thesis. And now he was there when I had my qualifying exam pain here at the University of Illinois. That was really horrible experience. I did pass. You can see I'm here. And for keeping me going through all my broken algorithm crises. You know, I would not have been able to do any of this without him. Now, Franco mentioned that I have my thesis. I just have to show you because I haven't had a chance to unpack my office yet. So I have a faculty office too. And I have like 8 boxes of unpacked things there. And I went up there, and the very first box I opened, because I was looking for my thesis, because I wanted to read my acknowledgement again. And I found it right away. But I read the acknowledgement. At the time, I was told it was too long, but I'm glad it made it that long. So, but anyways, you know, thank you all for coming here. Thank you for this great honor. And I think it's true that the reason that I've been able to do all these things throughout my career have been because of, you know, the foundation I got here. And, you know, I'm glad that now I have the opportunity to help provide that foundation to others. And we're doing a great job, and we're going to do a lot more exciting things in the future. Thank you.
Nancy already forgot her box, but it's all right. All right. It's all right. So, thank you, Nancy, and congratulations again for being named Abel Bliss Professor in Engineering. So, as we conclude today's formal program, we ask everyone who was involved in the ceremony to remain in the room for group photos. We invite everybody else to make your way to the atrium for reception, and we will join you momentarily. But before we truly close, I would like for the entire audience to congratulate again Professors Banerjee, Chikuri, Wano, and Amoto for their superb accomplishment and for their recognition today. thank you all for coming. Could I please add one comment? One more comment. Yes, please. Just a second.